This is a summary of graphs. Okay, the very first graph we're gonna do is a volcano graph. Okay, when you have when you have y equals to k over x squared, when your denominator is x squared, you will draw this graph. Okay, so it's gonna be Mount Fuji. Draw nice. Mount Fuji. Okay, know that these 2 points will never touch the x-axis, and these 2 points will never touch the y-axis. Okay, this is over x squared. Some examples over here you can see. You will see your indices. You can apply also. Next one is slanted alternatively. Okay, so when your denominator is power of 1, your graph will be like that. Okay, not very nice but get the idea. Okay, so similarly to that one, it will never touch the x or the y axis. Okay, the next one, y equals to kx power 0. Remember your indices, where anything the power 0 is always 1. Hence, this is the y equals to k graph. With y equals to k, how do you draw it? It's like that. Just one straight line. And it's cutting here. So this is actually k. So example, if y equals to -7, where is my line? My line is here. And it cuts here at -7. Okay? Alright, next one. Linear graph 2, y equals to kx to the power of 1. So this is a linear graph. So it is moving upwards. This is a positive graph. It's a positive graph because it's going upwards. If my coefficient is minus, that means it is a negative graph. If it's a negative graph, it will go the other way, from right to go left to right from the top. Okay, so this is positive, this is negative. Okay, for all these you just flip, then it's negative already. Next one, quadratic, bowl shape. Okay, something like that. Okay, this is a positive graph. Okay, if it's a negative graph, it will be like that. Okay, opposite bowl shape. This is called another word is called parabola. Okay, so a positive parabola will be happy face. If it's positive, it will be happy face, and happy face will be like that. If it's negative, it will be sad face. Sad face means it's like that. Okay, so you can, if you want to sketch graph in exam, you can do completing the square. You can factorize. Okay, next one, cubic. Cubic graph is going up like that. Okay, like that. Okay, so if it's a negative, it will be from top to bottom from the left. Are we clear? So this is a positive one. Next one, exponential graph. Y equals to a power x. I don't know if AE math have, but this one A math confirm have. So you just think of exponential graph, right? Like aeroplane. Okay, airplane take off. Okay, airplane take off. How does airplane take off? From the runway, right? So it's like that. Shoot outwards. Okay, shoot outward. Shoot upwards like that, and you cut the y-intercept at 1. Why? I'm gonna use this example. If I want to find my y-intercept, I must sub x equals 0, correct? You see here, if I sub x equals to 0, right, it'll be 7 power 0, e power 0, 1268 power 0. Anything about 0 is always 1. Hence, you'll always cut the y-axis at 1 unless it has a plus. So if I have a plus 3, the graph will go up 3 times. Hence, they'll cut the axis at 2. Okay. So for the asymptote of this graph is 2. No, the asymptote is the x-axis. Okay. What is the asymptote? Okay, so the asymptote is a line which the graph goes really close but never touches it. Okay, so the asymptote for this is the x-axis. So if I have this graph, right, if it's a plus 1, where is my asymptote? My asymptote will be x equals to 1, because if it's going up 1, right, this will cut the x-axis, cut the y-axis at y equals to 2. So the asymptote will be x equals to 1. Actually, right, I cannot assume that. I'm sorry. You try not to assume that, okay? Okay, I think I'll make a separate video on looking at asymptotes, okay? Next is the logarithm graph, okay? So, the logarithm graph is always a rocket shape outwards, okay? Rocket shape, should be like that. Like that, okay? Rocket shape, Can? Okay, so it may cut like that, then you must find whatever, okay? Yeah. Alright, so if it's a negative logarithm, if it's a negative graph, it's the other side. Okay?